All right, we're going to start our third day of graphing sine and cosine, and today the emphasis is going to be on shifts. Shifts up and down, okay? Shifts up and down, and left and right. And probably the easiest way to do this is to show you where those shifts come from in the function. So what I want to do is just show you what's called standard form. This is the complete messy form of a sine or cosine function. Y equals a sine of b times x minus h plus c. That is as messy as one can get with a sine or cosine function. Now we already know what some of these are. We already know what this is. That's my amplitude. I'm going to abbreviate. We already know what b is. That gives me my period. All right. But the good news is all our work we've done earlier in the year with transformations still works the same way. What do you think this plus c is? Is that my shift up or down? Okay, this tells me my vertical shift, whether it's up or down. And of course, h is going to be my shift left or right, my horizontal shift. All right? So it's really not that big a surprise. The best way to learn this is to just go ahead and tackle one. So let's take a look at our first example. Let's say that I wanted to graph y equals 3 sine of 2x minus pi halves plus 3. All right, let's start breaking this problem down. Obviously, my amplitude is 3. That's easy. And let's just take care of the easy parts first. There's going to be a vertical shift. This is going to move every point up 3. All right? Now, the next thing, and this is I don't know if I'd call it hard or not, but this is the challenging part of these problems, is dealing with the period and the horizontal shift. So, if we go back, you see that this b is outside parentheses. All right? So if I look at my problem here, this 2 is inside, which means I need to factor it out. And this is the part that sometimes people struggle with. So let's factor this 2 out. This is going to become 2 times x minus pi fourths. Now let's think about why that's the way it works. You have to think distributive property backwards. 2 times x will give me my 2x. And isn't 2 over 1 times pi over 4, if I do my factoring, don't I get my pi halves, which is what I had? All right? So you have to think backwards, and it helps to just even, set up your distributive property and try it. So now we're ready to graph this thing, okay? Almost. Sorry, we need to take care of my period. My period is 2 pi divided by 2, so my period is pi. Our process is still the same. The next thing I need to do is road markers. Okay? So my road markers are going to be pi times 1/4, which is pi fourths. All right? So we're ready to start graphing this thing. By the way, what is the shift right or left? The shift is this form right here after you factored it out. So this is going to be a shift right pi fourths. Okay, so we got a lot of things going on with this one. So what you want to do, since I know I'm moving this thing to the right, is I want to allow plenty of room here off to the right. Now my period, I'm told, is pi. So I'm going to, just like before, go ahead and mark off my ending point. There's my period of pi. And I put my quadrants in, just like before. I know that my road markers are pi fourths. So I'm going to go 1 pi fourths, 2 pi fourths, 3 pi fourths. And this one, of course, is 4 pi fourths. And wouldn't the next one be 5 pi fourths? Couldn't I just keep going if I needed to? I could, because I might need those when I do my shift in a second. All right? So my amplitude was 3. I'm going to make this kind of short so that I have room to move it in a minute. So there's 3, there's -3, and now I can put in my dots. We're doing sine, so I start at 0, 0, 3, 0, -3, 0. All right? Now, the only thing, I have two things that I have not taken care of. Here's my preliminary graph. And you need to do this, which is why I made sure you had a colored pencil. You need to sketch this, and then we're going to move it again. All right? So look what we've got now. Now I need to shift this thing right pi fourths. So how does that work? I take every point and move it to the right pi fourths. So this point right here is going to go to the right pi fourths to right here. And then I'm going to take this point and move it to the right pi fourths to here. This point will go to the right to there. This point will go to the right to there. And this point will go pi fourths to the right to there. And now I can sketch my new graph, which is there. And I'm almost done. The hard part is over, because now, don't I have a vertical shift as well? I told you that this one was about as ugly as it can get. So now I'm going to pick a new color, and I'm going to go move each of these points up 3 units. So this point is going to go up 3 to, instead of being on 0, it's going to be at 3. I need some more lines here on my graph. 4, 5, 6. And so then I need to take this point and move it up 3, which will put it at 6. This point up 3, which will put it at 3. This point up 3, which will put it at 0. And this point up 3, which will put it at 3. And now I can connect the dots. And that would be my final graph of one period of this function, the one in green right here. And that is, pretty messy, but there really is no other way to do it. We have to find my period, I have to sketch a base graph, and then I have to move it a couple times. So this graph right here in green is my final version. All right, let's do one more, kind of dealing with a different situation that was not in this last one. Let's say that I have y equals 1/2 the cosine of x plus pi thirds. Now this one is easier in some senses because I don't have to factor anything out of the parentheses, do I? All right? If you notice, this number right here is 1, right? So I don't need to factor out a 1. I just know that the period is going to be what? The period is just going to be 2 pi. Okay? If that number right there in front of x is 1, 2 pi divided by 1 is still 2 pi. All right? So if I do 2 pi divided by 1, I still get 2 pi. So there's my period. That helps. Is there any vertical shift? No. No vertical shift. I'll just put no VS, no vertical shift. I do know my amplitude is 1/2. And I do have a horizontal shift. Which direction? Left. This one is left pi thirds. And that's what's going to create the challenge on this problem. So I'll show you what the challenge is in a second. Let's get started here. I don't have any vertical shift to worry about, so I'll just put it right here in the middle. Actually, I want to leave some space here because I know what's going to happen to this graph in a second. I'm going to make this thing about right here, like that. And my period is 2 pi. So there's 2 pi. Break up my quadrants. I know that this is going to be pi, this is going to be pi halves, and this is going to be 3 pi halves. All right, because I have a standard period on this one, which is 2 pi. My amplitude is 1/2. Okay, up here's 1, and then down here's negative 1/2. And I am ready to put in my preliminary graph, which is starts at this value for cosines instead of starting at 0. So I go here, 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 and here for cosine. There is my preliminary graph. Okay? Now, here is the main tricky part to this problem, is the shift left. Because you'll notice my shift is different from my road markers, isn't it? Yes. On the last problem, my shift was pi fourths, and my road markers were pi fourths, which makes it kind of handy. But on this one, my shift is not the same thing as my road markers, which are pi halves. So this means we have to do some fraction work, is what it means. So what I need to do, let's start here with this pi halves. I need to move this left pi thirds. What that means is I need to do a subtraction problem. I need to do pi halves minus pi thirds. And when I subtract with fractions, I have to get a common denominator. So what is the common denominator here? 6. So that means I need to multiply this one by 3 over 3, and I need to multiply this one by 2 over 2 to get my common denominator. So what I'm going to have is 3 pi sixths minus 2 pi sixths, which is what? 1 pi sixth. And guess what? That is my first point. Okay? So this point right here, actually it's my second point, but just give me a second. This point right here goes to the left 2 pi sixth. Okay? Now, this first point, I should have taken care of this one first. This one goes to the left. It goes left pi thirds, right? That one's easier, isn't it? Because isn't this 0 right here? So isn't this just going to be at negative pi thirds? Let me get a new color for my new points here. That one will be there, and now I have 2 of the points. Okay? I've moved 2 of them to the left. Now I need to move this one to the left pi thirds. So now I'm going to do pi minus pi thirds. Well, what if I had 1 minus 1/3? Wouldn't it be 2/3, right? If I was doing 1 minus 1/3, isn't that 2/3? So that means this point is going to be 2 pi thirds. And it's this point right here that gets moved, so now it is here. This should be a slash. All right, we're getting closer. Now I need to move the 3 pi halves. So that means I need to subtract pi thirds. 3 pi halves minus pi thirds means I have to get a common denominator again, which is 6. So I'm going to multiply the first one by 3, make it 9 pi sixths minus, this one's by 2, this one will be 2 pi sixths. So 9 minus 2 is 7 pi sixths. So this point right here is going to be 7 pi sixths. And now I am here. I just have one more, thank goodness. All right. Let me fix this here in the middle. That's not supposed to be a point. It's just supposed to be a dash. All right, and then one last thing, I need to subtract pi thirds from 2 pi. 2 pi minus pi thirds, well, that's going to be like 6 pi thirds minus 1 pi third, which will be 5 pi thirds. And there is my last point here at 5 pi thirds. And it is up, I need to erase, my point's going to be right here in the middle of that mess, sorry. So now I can finally connect the dots and get my new graph. That one is extremely ugly because of all the fraction work. All right? So if you manage your fraction work on that problem, it will not be that bad. And we will stop there for today.